Today, we're going to talk about protocols and their impact on Star Citizen. I've had quite a few questions about this over the last few days. I've also had some feedback that it's hard to reach out to me as the only method right now is in comments, and I just can't keep up with all of them as much as I'd like to. In an effort to correct that, I've created a Discord server. I'll put the link in the description below and add it to the channel links. I'll be doing my best to be available there when work and personal life allows. Firstly, I think we need to break down the various protocols and acronyms into some high-level buckets. Once we do that, I'll try to give a very brief high-level explanation as to the relevant ones. Almost all of these will come up in the series I'm running on networking in much more detail. So keep your eye out for episodes there that pique your interest. First, we have the application protocols. These would be protocols like HTTP and SMTP, the two protocols that make the web and email work respectively. They are endpoints of networking, not a function of networking. You talk to an HTTP service. It doesn't impact how you get to it. Second, we have the transmission protocols. Mostly this consists of TCP and UDP. TCP being used for reliable data exchange and UDP for unreliable. There are quite a few other more niche protocols that fit in here, like NetBIOS, iSCSI, which aren't relevant at the moment. Thirdly, we have function protocols. These are protocols used to run or manage a network. They deal with anything from routing packets to exchanging information between different networks. This is the largest group as there are many functions here, but they manage the how of a network. How do I get this packet where it's going? How do I get an address? How do I create a protected service? For this conversation, I'm going to skip spending time on the application and most of the function protocols. Not that they aren't critically important, but rather they don't directly relate to Star Citizen. If you've watched my video on the OSI model, the transmission protocols operate at layer 4, the transmission layer. These are meant for one device on the network to communicate with another. What that communication contains is irrelevant. The goal of the connection is to just open the line for the two host stacks to talk to each other. TCP, or Transmission Control Protocol, is a reliable protocol. Before the information is passed up from layer 4, TCP makes sure that some things are in place. First, it has error correction. So if there are missing or corrupted packets, there are methods in place to correct that by requesting a retransmission. Second, it orders the packets when they get to the host out of order. This ensures that the upper layers have a clean stream of data to work on without having to create their own individual solutions to reliability issues. TCP also has the concept of windowing, so it will grow the size of the packet until it starts running into errors, drop packets and the like. Then it will reset the window size lower in order to try to maximize throughput. This is actually frustrating for people like me. If we ever get into queuing and drop hashes, I'll explain why. But for now, just know that it has this function. UDP, or User Datagram Protocol, is used when reliability isn't important. Normally, this is because if a packet is lost or corrupted, by the time a retransmission and reordering correction is done, the value of that packet has been lost. This is very common in voice over IP and streaming video. It's far better to skip the missing data than inject even a small delay to correct it. In the early days of online gaming, when we were using modems, this was the constant nightmare. Playing Quake and having a head-to-head fight with someone who had packet loss was like shooting at Nightcrawler. They rubber banded all over the place when a position update finally made it through the packet loss and queue drops. Why one is chosen over the other is rather obvious, but the reason we don't just use TCP for everything is that there is an overhead for that reliability. Now, in the modern world, with operating systems able to offload the work to the network controller, the server-side difference on resource usage as a factor has lost most of its impact. However, the value for data transmission that doesn't have to be reliable is still in place, as UDP will always be slightly faster than TCP, unless the network path is almost perfectly clean or the ability to grow the window size will benefit the application's needs. The decision to use TCP or UDP is for the application to make. Is the small gain in performance worth the loss of reliability? Does the use case mean that errored packets are useless anyway? The next set of protocols are functional protocols. This is going a bit further than anything we've talked about before. I'll get into the details in other videos, as this is one of the most fascinating and complicated areas of networking. For now, I'm going to just try to group the protocols into buckets so we can talk about them. An IGP, or an Interior Gateway Protocol, such as ISIS and OSPF, are the two main protocols used that define a network. The function here is the ability of any connected device to be able to talk to any other connected device across the routing domain. Commonly, it's represented as a cloud, as it constitutes a single zone of authority. One group or organization controls access, policy, and the structure of this network. EGPs, or Exterior Gateway Protocols. This is BGP, or more specifically eBGP, and this is how networks we just defined exchange information. This is done by each network sending its peers a list of address space that it has a path to get to. I also need to mention the concept of MPBGP and IBGP. MPBGP is multi-protocol BGP, which allows for the exchange of address types other than IP without mingling them together. IBGP is internal BGP, which is used to give each router a next hop for the traffic leaving the network. There are a few hours of conversation here to even get the general function across, but BGP is the glue that holds the networks of the internet together. Finally, we have the use case protocols. This includes LDP, RSVP, IGMP, segment routing, etc. These are protocols that function mostly within one network to extend the capability past what pure IP can offer. In modern networks, these are commonly used to improve performance by offloading packet routing, route traffic based on congestion, or enable services like VPNs. The standout for this conversation is IGMP, Internet Group Management Protocol, which enables multicast. Multicast is a special case, so let's go over that. Let's use my first experience in the 90s with multicast as an example. At the time, the bandwidth of the backbone was tiny, and people smarter than I were trying to figure out how to enable video services. As video at the time was broadcast in cable TV, the problem they were trying to solve is how can we let hundreds or thousands of people watch a broadcast at the same time without blowing up the network. To do this, IGMP creates a tree across the network. This fits into the same logical space as OSPF and ISIS as it defines the route to deliver traffic. However, what multicast brings to the table is the ability to replicate packets. So once the tree is built, the source sends a single data stream into its IGMP neighbor. That device then sends a single data stream down to each branch of the tree, and that continues until all the clients get the data stream. However, at each hop, the data stream uses the same amount of capacity. In my example, we were working to show a shuttle launch from NASA, a broadcast across not only our network, but all the regional networks at the time. This required not only IGMP, but IGMP across network boundaries. The only good analogy I can come up with here is something that will date me, but we all know I'm old, so I'll run with it. Think of it like a phone tree from before we had email or text messaging. You have a root, someone that makes the first two calls. The two people called each then call two more people, and so on, such that the message is received once and then propagated down to the next steps of the tree. Multicast does work and is very cool as an exercise. However, there were complications with it. Multicast is one of those protocols that has windows of value. The internet has functioned for years in a cycle where we get a jump in capacity, like going from a DS3 with 45 megabits per second to an OC3 at 155 megabits per second. Suddenly, we had lots of headroom, and these more efficiency-focused protocols became less important. As the usage grew, we started having capacity issues. Suddenly, they were back in the conversation. That tug of war with multicast has always been about complexity versus value. The overhead to support it has always been tricky. It's not as common, as most vendors haven't optimized it as well as they have unicast forwarding. Also, it requires rather specialized support from every network along the path, which I'm not sure is an assumption I'd want to make personally. To be honest, other than clustering or high availability, I haven't heard it come up much in the last decade or so in my conversations with customers. I would like to take a moment here to inject another term into the conversation, as there's a new structure in use today that addresses some of the multicast use cases. These are called message buses, such as Kafka or Pulsar, and are designed for a system to publish information to clients who subscribe to hear it. This gives the server-side benefit of multicast in terms of send once, while allowing the clients to pick and choose the information they're going to receive. Think of it like an email list. The sending process sets up a topic or a channel on the bus, then sends information to that channel. Clients, email recipients, can subscribe to that topic to receive the message, and then they're responsible for checking to see if that message matters to them. In effect, this is an application layer implementation of multicast that has the application layer benefits without depending on the networks supporting IGMP to work in a broad implementation. Time for my opinion here. I find it much more likely that if CIG is using any form of send once structure, it would be a message bus. Depending on the amount of single target traffic, I would mix in unicast, as a single receiver on a topic or partition might not be worth the overhead of creating and managing them. I'd like to finish up by saying that engineers work by discussion. I don't know everything possible about networks. I learn more every day. I hope I've reflected in my responses to comments and my follow-ups and corrections that I enjoy having discussions and considering alternate ideas. If I haven't, I'll double down on trying to keep up with doing so. Finally, I don't want to imply that I know anything about what CIG is doing. We are discussing and debating what they could do. And in this case, my opinion has just as much weight as anyone else's. Ideas are not facts, and we are all operating on what seem to be logical assumptions to us. That doesn't mean I'm right about the conclusions, but I do everything I can to be accurate on the facts about how networks function and the considerations that come about due to that. I hope I haven't confused people too much, but I look forward to these conversations. I enjoy them. I would appreciate a like if you found value in this, and for more content like this, please consider subscribing. Thank you very much for your time.